Hello, good morning, everybody. At first, let me thank the organizers for inviting me. I'm talking about military applications of nanotechnology, and I give it a special twist today in trying to get it linked to some fundamental questions of ethics. So this is what I'm going to talk about. I'll give you some information on just war theory. I'll then explain how military preparations can lead to wars. I'll talk about arms control and disarmament. I'll have a glimpse on the role of new military technology, including in shaping the international system. I'll list potential military applications of nanotechnology, have a look at military research and development in this area, and then explaining the role of preventive arms control in general and what it might mean applied to military applications of nanotechnology, and then I'll end up with final considerations. I should mention that I have authored a book which you can look at to many of these things in great detail, and there is a report that one can download from the internet for free. Okay, so if one thinks about ethics applied to questions of war and peace, for many people the first things that come to mind is just war theory. The theory is very old, but it has been refined over the decades and centuries. The theory says not every war is just in a moral sense, but there may be some wars that are moral and just, and they have to fulfill certain conditions to be so. So the one set of conditions concerns when it is justified to start a war, to go to war. In the legal term, it's the jus ad bellum. The second set of conditions is about how the war is being waged, and sometimes a third set of conditions is being added, obligations that concern the situation after the war. So the first set of conditions, the jus ad bellum, has several conditions that need to be fulfilled simultaneously. So in order for a war to be just, you need a just cause. This must be the last resort of redressing a bad situation. There must be a decision by a proper authority with a public declaration of this decision. There must be the right intention. There must be a probability of success of the war. And the means that you choose must be proportional to the end that is being looked for. Concerning the second set of criteria, the jus in bello, it is much more refined. Even though I only list two general categories here, the various refined rules can be grouped under the criteria of, on the one hand, discrimination. That is, you can not attack everything. Civilians must not be attacked. Combatants are the ones that can be attacked. But if they are hors de combat, like raising their hands or unconscious or wounded, you can no longer attack them, and many such rules. And there is a rule of proportionality. So the amount of destruction that is being inflicted must be somehow proportional to the military gain that one expects from a certain attack. So, and the final word on just war theory is that these two groups of categories are independent. The second one is much more stringent. It's legal. There are obligations, and by now there's also an international criminal court. So the rules of war, how you wage war, the jus in bello, hold for any party taking part in a war, even though it is an unjust war. Even in a war of aggression, which is by definition unjust, the rules of war need to be followed strictly, and people can be held responsible. Second chapter, just war focuses more or less on the question when a war is justified, or if a war is justified, and the conditions. In looking at that, it somehow overlooks the question that one should rather prevent war. It's somehow there in this idea of war must be the last resort, but it's not very explicit. So I think if one looks in an ethical way at the question of war and peace, one should be more explicit on this question, have we used all means available before using the last resort? This includes also general policies of détente and cooperation. In particular, there's one specific problem, which political science calls the security dilemma. Problem is, we have an international system which is still characterized by an absence of overarching authority as we have within states, which guarantees the security of individual citizens, and maybe with some exception in this country, but in many other countries, citizens need not bear arms to be more or less secure because there's police and jurisdiction and all kinds of things. So we don't have these things in the international realm. So how do states make themselves secure from attack by others, from aggression? They build up armed forces to defend themselves. The problem, however, there in this process, they increase the threat to others if they don't take very much care to be just building defensive things. Most things that you build for armed forces can be used for both offense and defense. So in the process of all countries trying to make themselves more secure against aggression, they, as a system, looked from above, decrease their overall security. The threats are being increased by your collective endeavor to increase security. So the security is, they try to increase the security, but in fact it's decreased in the overall system. That's what makes the security dilemma. There are several ways out of this dilemma. I'm not discussing, for time reasons, all of them, but I mention at least one. That is the voluntary limitation by international agreement between potential opponents of their armed forces or their armaments. This is generally called arms control, and I'll explain a little more about this now in the next chapter. Arms control is about reducing military threats by agreed limitation of weapons or forces. Disarmament goes a little further, which it really means reduction of armaments, in the ideal case up to zero. So it's a continuum from abolishing certain classes of weapons. We have a general ban valid in the Biological Weapons Convention. States must not have biological weapons. They must not only not have them, they must not develop them. Same holds for chemical weapons. There is a certain class of intermediate range nuclear missiles with ranges between 500 and 5,500 kilometers, which were built down, which were reduced to zero by a certain treaty, the INF Treaty, Intermediate Range Nuclear Forces Treaty in 1987. So that's disarmament, and the end game, the end status, which is enshrined in many UN declarations and also many arms control treaties, which them in the preambles, the treaties themselves are much more limited, but in the preambles they say this all is a step towards general and complete disarmament. General meaning all states, and complete meaning all armed forces. Okay, but as long as there are armed forces around and states find them important to feel somehow secure against aggression, you have a friction. The armed forces are being kept to guarantee victory should war nevertheless occur. On the other hand, you want to sit down with potential enemies and agree about limitations of their capabilities and numbers. So there is a certain problem here, but there were instances in history when states nevertheless sat down and agreed on certain limitations, and with the upcoming or with the new administration in this country, things may get going back again. But we have to be clear that looking from an ELSA standpoint or from a technology assessment standpoint, there is a conceptually very different context for technology assessment and the regulation of technology than we have in the civilian realm. In the civilian realm, you may have some dangerous technologies, toxic chemicals, explosives, what have you. Then the state, by its democratic processes, develops certain regulation. You may need to have a license to handle something, and so on. But no such thing at the moment exists on the international level. So what we have to do, or what states have to do in order to limit military uses of technologies, you have to sit down and make an international agreement, which is a tedious process and not a routine one. They have to decide voluntarily to take part in such negotiations and such signatures of treaties. And in doing so, they try to nevertheless guarantee that the combat strength that they find necessary for their armed forces is still maintained. And there is a fourth problem that the military needs some forms of secrecy. So you have a problem with verifying or with agreeing on verification methods. The military needs some secrecy for functioning on the one hand, but on the other hand, you need to be able to look into your opponent's military capabilities, whether he's really complying with the obligations of a treaty. Okay, fourth section, new military technology. If one looks back into history, qualitative superiority in military technology, arms was instrumental, in conquering other countries, seizing colonies, and so on. Think of the history of this country for the moment. Fire weapons against archers, longbows against powder guns, and so on in Europe. And science and technology, in bringing about new types of weapons, have adopted a new, much more prominent role since World War II. And they have contributed to shaping the international system. This holds in particular for the nuclear bomb, obviously. So the international priorities have changed, in a sense, from a state where it was kind of normal to go to war to at least try to avoid large power, superpower war, nuclear war, because it would have meant annihilation of the respective cities, states, and maybe civilization as we know it. Nevertheless, again, this friction, we had permanent efforts in military technology to somehow gain the upper hand, not only in nuclear weapons technologies, but also in many others, conventional ones, maybe some unusual ones, etc. So the question I am at the moment only posing, following the philosopher of yesterday evening or yesterday afternoon, will nanotechnology again bring marked change in military technologies that have important influence on the international system? If that were so, one could in fact say, well, yes, we have a certain nanoethics for war and peace. The question which was also hinted at already yesterday, is there a special nanoethics or is there not? And at the end, I'll try to be a little bit more explicit on this question. So, in my study of the potential military applications of nanotechnology, which, by the way, was funded by the German Foundation for Peace Research a couple of years ago and which led to this book which I mentioned, I have found some 21 general areas where nanotechnology could find use in the military. This starts at the more generic categories such as electronics, computers, communication. You might have a fingernail-sized, very capable computer in every kind of weapon system, even in some small munitions. Software will become much more powerful, more autonomous. Materials will become more lightweight, much stronger, and maybe smart. Energy sources and propulsion will become smaller and more efficient. Propellants and explosives will gain in efficiency. There will be miniature biological and chemical analysis systems. There will be camouflage, which changes color, so adapting itself in real time to the background as it is being seen from the opponent. Sensors and sensor networks will become very small and very cheap so that they might be scattered around on the battlefield in the thousands or maybe hundreds of thousands. At least some improvement is to be expected in light armor and bulletproof vests. I'm not so sure about heavy armor. Vehicles will become lighter, faster, and more agile. Munitions and missiles will become more precise and smaller, maybe down to this size, a little missile, which seeks out an aircraft and, well, in order to hit it, cannot just explode in 5 meters distance. This would be too little effect. But if it seeks out, let's say, the cockpit window and just crashes through it and then explodes 20 grams of explosive, this would, of course, down the aircraft. Could be a military one, could be a civilian one. I'll come to that later. Miniature satellites and launchers will become possible. Satellites this size have already been flown, but with limited capability. It will become much more capable in the future. They might be launched by launchers, rockets this size, 2 meters maybe. We will have macro robots and micro robots with and without weapons, including biotechnical hybrids, that is, electrode-controlled insects and rats or other little animals. There is already work on soldier systems which sense body status and maybe manipulate the body, and there is work on a brain-machine interface for somewhat faster reaction, maybe by pilots or other soldiers. You gain maybe half of a tenth of a second in reaction time if you bypass the nerve channel from the motor cortex to the muscle and then the actual movement of a finger to pull a trigger or whatever. In nuclear weapons, not much qualitative improvement is to be expected, except in a very fictitious case, which I don't really want to discuss about at the moment. However, we will get a big problem with potential new chemical or biological weapons, which will be able to act in a very targeted way, maybe recognizing a certain DNA pattern or a certain protein pattern, and only if the correct pattern is being sensed, then releasing a toxin, either killing or incapacitating or what have you. And this could be, in the future, maybe, I don't know, 10 or 15, 20 years, you give a certain drug to 8 billion people worldwide, and just one will be affected. If you have a saliva sample of that person beforehand to just write the correct DNA sequence into the agent. Some of these applications are 5 years away, but most of them 10 to 20, and some maybe take even longer time. And not for everything it is guaranteed that the hopes that people in research and development put into it will come true, of course. Some things may just remain unfeasible or too expensive to really be developed in high numbers or for many soldiers. Sixth section is on actual military research and development in nanotechnology taking place at the moment. And here the fact is that most of such activities are taking place in the US since a couple of years. Since its foundation, in the National Nanotechnology Initiative, about 1/4 to 1/3 of the money has gone to the Department of Defense. You see here the time development. On the left-hand side, the absolute figures for the NNI in total, and the lower one is the absolute figure for the Department of Defense. And the thick curve with the scale on the right shows the percentage. I'm not sure whether the slight decrease here is due to the policies of the new administration, that's for the coming federal fiscal year, or whether it's due to the economic crisis, which has led to some reduction in military spending for R&D in general. I leave this as a question for the experts in this country. This work in the US is mainly being done at universities and some at armed forces laboratories and some at nuclear weapons laboratories, but much of it is still at the basic level, the basic research or maybe the technology development level. There's not yet real development of systems that could be painted olive green and delivered to the armed forces. Some flashlights on activities. There is one high priority of the Department of Defense in the US to have uninhabited combat vehicles, which might even become autonomous, even in deciding on what to attack and whom to kill. This is, again, maybe 20 years off. And at the moment, it's not explicitly linked to nanotechnology, but nanotechnology will provide many means of making such vehicles more intelligent, more capable to decide, to take in and understand the context, will give better materials for having them lighter and more agile, and better energy and propulsion systems. I should also mention the potential for microrobots, as I did already. In particular, there is work being done on hybrid systems where instead of building a small robot from scratch, all artificial, which is of course a difficult task, you use the hardware that nature provides in using an insect or a rat, a small mammal, and just implant electrodes in order to control its movement and put a little backpack with some intelligence gathering device or maybe a little explosive on top of it. So the hardware for traveling, for energy supply, for orientation and so on is already there. So you save and just take over control of the animal. The other way around, taking signals from the brain and inputting it into some machine, the brain-machine interface idea, has been worked on in animal experiments where a monkey was implanted with a set of multi-electrodes in the motor cortex, and the researchers were able to understand the neural signals when the monkey wanted to move his arm. And then they controlled the robot arm with that, and finally the monkey was able to use the robot arm to get the banana. And another actual research project that is being looked at here with some connection to nanotechnology, there's the idea of modifying the biochemistry of the human body with soldiers so that they would be able to fight actively at high intensity for 7 days and nights consecutively without sleep deprivation, or to work or fight 3 days without calorie input. Short look at military nanotechnology in other countries. There are developed or industrial countries who do something there, but it's much less than in the US. It's not hundreds of millions of dollars per year, just a few millions of dollars per year. In Germany, my country, it's at present practically nothing. In Russia and China, they are active in this area, though there's not much known, but obviously they spend much less, but they are principally capable actors in nanotechnology, as the specialists can certainly attest to. So a cautious estimate arrives at the situation that the US is spending 4 to 10 times the rest of the world in military research and development of nanotechnology, which is 80 to 90% of global spending. Whereas in military research and development overall, it's only, in quotation marks, 2/3 of the global, what the US spends. We can think whether it's really justified, whether 2/3 of the future threats in the world is directed at the US, so that such a high amount of spending was really justified. But that was a side remark. So, but this ratio of 80 to 90% is likely to change as others will catch speed and will follow the US role model in going into the military field and nanotechnology, depending, of course, on the success that such programs will have in the US as well. So the US is the big precedent and role model here. And I should mention that activities have already started also in India, Brazil, South Africa, and Iran. And it's quite obvious that many other countries, take Singapore, take Saudi Arabia, and so on, will become more active in the military applications if there's nothing like an international ban in place. So, penultimate section on preventive arms control. This is the ban or the limitation on militarily usable technology or weapon systems before they are being acquired and deployed for the armed forces. That's not completely dream work. It's not blue sky. We have several precedents and existing arms control agreements. I don't go through all of them, but in many of those which are listed here, you have explicit prohibitions of already development of certain things. Take chemical weapons, biological weapons, and let's say, take the last one, the blinding laser protocol of 1995. Laser weapons intentionally developed to permanently blind soldiers were banned before they were being fully developed. And every country up to now has abided by this protocol. Preventive arms control goes in certain steps. At first, you have a scientific section where you do a prospective analysis of technical properties on potential military uses. Then you assess the knowledge that you have got under certain criteria, and then you devise possible limits and verification methods, and then hopefully states will sit down and negotiate according to the analysis that arms control science and peace research science has delivered. Not always it goes like this, unfortunately. So these are the criteria. They can be grouped in 3 general groups. First group has to do with the existing arms control and disarmament and international law of warfare efforts. Second group has to do with the stability between potential opponents. Do certain new weapon systems incite escalation in a crisis or from a crisis into war, or do they not? And is there danger for special arms races, or is there danger for proliferation into, let's say, crisis regions? And the third group has to do with military uses which may have already in peacetime certain consequences for civilian society, either by toxic materials that are being released or that could be released, or by providing tools that terrorists could use in criminal acts. So I have applied these criteria to the potential uses of the 21 areas that I found of military uses of nanotechnology, and I have found that several generic applications don't pose big problems or are just too close to civilian uses to consider limitation. Think of little computers. Everybody has a computer in the buttons of the shirt. We couldn't ban them from soldiers using them. There are very few specific applications which get positive marks. This applies mainly to cheaper sensors for biological and chemical agents that could be used, let's say, in public spaces in the civilian realm. But there are several applications which pose serious dangers, and you see them here grouped by the category that is mostly affected of the criteria. So it starts at distributed small sensors, which could be used for in civilian realm for invading into privacy. We had this argument yesterday already. And it ends with new chemical and biological weapons. I have thought about what could be done, and I have developed certain recommendations limiting or prohibiting such systems embedded in the general arms control process with detailed rules and definitions. And in order to be comprehensive, you have to include civilian applications. Details can be looked up in the book. And the verification of compliance would mostly be done with traditional methods of on-site inspection, which will not hold for very long. So final considerations. We have a fundamental problem here. We get a revolutionary technology, and how do we deal with it on the international level? One approach is, quote, reduce the likelihood of war by providing an overwhelming US technological advantage, or it is essential to be technologically as far ahead of potential opponents as possible. That's the quote from the National Nanotechnology Initiative 7 years ago. Unfortunately, this approach overlooks certain things, interactions in the international system, and the danger to the US itself that might evolve from proliferation of such system. The US may be able to keep and maintain a lead or even a monopoly, but not for long. Other potential opponents will be able to do the same thing after a couple of years. And they could use nanotechnology-enabled weapons also in an asymmetrical fashion, and they could be proliferating to terrorists and used in this country as well. So I think that the US needs to understand that international preventive arms control in such areas is in its enlightened national interest. And again, the new administration may provide some better opportunity for understanding this and putting it into political action. However, in the medium to long run, we get a fundamental problem. Limitation and verification are getting more difficult. Nanotechnology is quite unlike nuclear technology. It will be widespread. Many applications will be very small. It may be possible to produce nanotechnology systems in small and very cheap facilities. So in this sense, nanotechnology is about like biotechnology, and we have a big dual-use problem. Civilian use, quite similar to military use. So in the future, we will need very intrusive monitoring and inspection for verification. Essentially, anytime, anywhere inspections, as is legal and possible for within states, for police purposes, for worker protection, whatever. So the question here is this intrusive verification still compatible with the military interest and secrecy? Secrecy is in part required for the very task of the military, namely gaining victory in armed conflict. And there may be the fear about too much loss of secrecy that the potential enemy could learn about weak spots in the military system that could be exploited for surprise attack. So the general question is, and I pose it as a question, it needs to be researched. Is the present international system capable of coping with the dangers of revolutionary technologies in the long run? If not, we have two alternatives: increasing military and technology threats, terrorist threats. Think of pre-deployed military robots, micro-robots inside the military systems of an opponent ready to strike at any time, or think of molecular hackers distributing unknown infectious agents that act generally or selectively. Or we learn to organize global security in a similar way as within states, with a monopoly of legitimate violence, with a democratized UNO, and international criminal law with the right to act within states, voluntarily reduce state sovereignty. Of course, this is a long and difficult path. First trends we have already, and I think an ethical approach should promote all steps in this direction. Side remark, I find it interesting that military applications, intentional destructive uses, are not yet systematically looked at in nanotechnology, ethical, legal, and societal aspects research. I call on you to add this to your research agendas. One needs to follow up military R&D in nanotechnology in various countries and investigate preventive arms control. So summarizing, I think an ethical approach to military uses should put the highest priority on the avoidance of large-scale war. Given political will, arms control with traditional verification methods will be able to contain the most dangerous military applications for 1 or 2 decades, but in the long run, international security may require a fundamental change in the international system. Thanks for your attention.